In front here still got a lot of vacant seats. Anyone can sit in front? How about the last row? Our gentleman at the last row. Can sit in front or not? Or this side? Yeah. Join the quiz, yeah? And don't forget to take attendance also. Okay, so I guess now it's 4:15. We're going to start the quiz. How to start? Yes. Start. Hey, can you start it? Hey, can you start it? Okay, please attend the quiz, yeah? Can I change the song? Change the song to the what? To the very famous Kemusan song. It's okay. Next time see whether we can change it. Those who cannot answer even one question, ask him or her come out and dance. Okay. How many questions? 10 questions. Sheldon, why you not attending last one?
Oh, I'm waiting.
Oi, that's it. Who is triggering this one? Must be our cast rep. Huh? Okay, so anyone haven't complete yet? Okay. Who is this people? Four, 6, 9, 3, 7. Who is 013? Raise up. Okay. Okay, so who still got wait for another. I will wait for another 10 minutes. Okay, after that have to end the quiz already. Okay. Where you buy this one? Finish already.
Yeah.
Finish already.
Finish.
Where you bought this sticker? You are the CSS to my 50 and
Oh, this one last 2 sem got one activity lecture mobile application lecture
老师给的。
他们有人外面的团体过来访
This one you can send to your girlfriend. You are my CSS to my used to be the CSS to my Wow, very meaningful. Okay. Provided your girlfriend know computer. Okay. Yeah, website design lah. Who is still in the starting point? Okay, anyone still haven't complete yet? Anyone, any student haven't completed the quiz yet? All computer, is it? All computer. Okay, so let us look at the end. Yes. Who is Sakamoto? Sakamoto Chin, is it? Scroll up. Yes. ELTS. So many. 38% growth, 34 pages. Okay, let us see. The highest point is Sakamoto Chi. Is there any special meaning in the word Sakamoto? No, okay. If got special meaning, I guess I better don't spell it out. Okay. So, Rock Uchi. Okay, ELTS. So you can see that this is your statistic from the quiz. Okay, now let us back to home. And so many quizzes. Okay, so now let us, I'll show you the answer. Okay. So what is the purpose of software maintenance? Select the best one. To make sure the software is keep operating. Okay. So to modify the system so that it has new features is a part of the software maintenance. Okay. So however, the best answer should be the third one. The developer is changing the code so that it perform better. That's referred to definitely is a perfective maintenance now. Okay. Which of the following is the correct order of maintenance process? Identify the problem, perform analysis, design, implement, testing, and deliver. Okay, it's some sort of like your software development cycle. Number 4, why perfective and preventive maintenance are proactive activity? Normally, it's the developer initiative, okay, to perform the task. Example of E-type system or E-type program. More than one answer. Food ordering, yes. Inventory, yes. Operating, yes. The last one, no. Okay, why? Because rectangle calculation, how is evolved? The formula is fixed already, right? Isn't it? E-type program is an emergency type program. It's not necessary to have complete problem specification. It's a part of the real world. Affect the world it is embedded in. So the correct answer is the last, the 2, 3, and 4. Okay. S-type program, all specifications are thoroughly defined, accepted when it's correct in terms of its specification. Modification must not have an impact on the mapping between input and output. Okay. P-type program have clear specification, accepted if the output of the program is practicable to the stakeholder based on the realistic abstraction of the problem. Probably type program no. Okay, answer is 1, 3, and 4. CSS stage model. Okay, the initial version is the first release. Yes. Other than that, may return to evolution no. Difficult to track no. No changes in service stage no. Okay, so the answer is 3. CSS stands for closed source software. Okay. Got any student answer wrong this one? No, okay. So flaws for FOSS stage model, difficult to track its evolution, yes. Initial version must not be the only version, no. Okay. Easy to track evolution, no. May evolve again from servicing, type of mistake, and phase out stages, yes. 1 and 4 is the answer. FOSS stands for Free Liberal Open Source Software. Okay. Maintaining component-based system, CBS, component-based system, has the following difficulty. Frozen functionality, yes. Trojan horse, yes. Unreliable middleware, yes. Effective middleware, no. Okay, this is the benefit. Iterative enhancement model, okay, is one of the model fall under the reuse-oriented model, okay. So based on the Japanese concept of Kaizen, yes, it follow a series of formal steps or stages, okay. Changes are made from highest level document and propagate to the code level, means from the analysis and to the implementation of code, okay. Redesign system based on the existing one, yes. This one is reuse, okay. We reuse, we analyze, okay, which one the problem, which one can reuse, then we design, modify it, and then we put it, and then we test it, and we implement it. Understand? Okay. So full reuse model is we have already discussed during the tutorial, which is there is a repository. Then if any maintenance task, then we look inside the repository. Is there any suitable artifacts or item can be reused? Understand? Build new system by reusing item from repository. Perform requirement analysis. Use previous version of system artifact. Yes. Directly amend code. No. Factors that affect software evolution. Oh, so many. Factors that affect software evolution. User expectation, yes. Operation environment, yes. Resources, yes. Theory of evolution, no. Software maintenance has existing test data, yes. Activity time period is short, has different category. Yes or no? Difficult to apply due to business rule, no. Okay. So now the second one. Software maintenance has different category. Correct or not? Correct, right? Isn't it? Okay. Perfective, effective. Okay. So this is the answer also. Concept category affecting software maintenance. All people way, maintenance process, the product, and the organization process. So activity-based maintenance category are corrective and enhancement. Okay. Hopefully you can still recall. I am a good student, definitely lah. Okay. So, software evolution, software become better, yes. Software become worse if not handling well, yes. New version of software is produced, yes. Software is changing, yes. Understand? Okay. So this is the answer. Okay. Now, anything else? Any questions for the last 4 chapters? For the previous 4 chapters, class? Any questions for the previous 4 chapters? No questions, then we may continue with the new chapter 5, configuration management. Software configuration management. Okay? So, this chapter is very short, okay? I guess today you can go back a bit earlier. Okay, now, software configuration management. Okay. What is meant by software configuration management? So, actually, when we design or we develop when we design and we develop a system, okay, so definitely we need to know, okay, what is the item involved in our project development. You understand? Okay. So let's say for example, who are the person involved, who is the stakeholder, what are the tools required, okay, what kind of documentation we should produce, okay, what kind of test cases we should have. Am I right? Okay. What is the cost? And somehow we need to know that, okay, what kind of methodology we follow. If we follow a certain methodology, what are the process or stages we shall follow? Understand? Okay. and what are the existing code we need to use, what is the API that we need to include in our project, and so on. Am I right? Okay. Different phrases may have different needs. Okay. Let's say for example, our requirement engineering phase. Okay. So we may need to identify, okay, who is the stakeholder, who is our supplier. Am I right? Okay. The requirement, how many requirements? How are we going to group the requirement together? Okay. So how are we going to find a requirement so that we are easy to find the requirement, and so on. So therefore, okay, same thing to do with the design, testing, and also the software maintenance phase. Okay, during the software maintenance phase, we may need to know that, okay, who is the person who raised the change request? Means that who is the person who find this issue, or who is the person who want some changes? Understand? Okay, and also we need to know that, okay, what is the previous change has been applied to this particular part of the system? What kind of tools is being used? Who is the person who make the changes? Understand? Okay? And these changes, okay, is affected which part of the system? You get me, class? Okay? And also, how frequent this type of error can happen? Okay? So this is those questions or those things that we need to maintain one. Okay, we need to keep. So therefore, we need to record every single activity happen in the maintenance, the information. For example, those who are the person who do the maintenance, who is the person who raised the request, what are the process we follow, what is the status now, any cost incur, who is the supplier, what kind of tools, where is the venue that we do this thing. You get me, understand? So by knowing this information, okay, is important for us to do analysis and important for us to perform a tracing. Okay, trace. Okay. So therefore, we come into therefore this software configuration management come inside. Okay. Software configuration management actually is for us to identify those items in our software project development or even software project maintenance, okay, and allow us to perform certain tasks, such as we allow us to trace back, okay, provide traceability of our maintenance record, okay, allow, okay, audit to our maintenance, understand? Okay, so imagine that if you are doing your software maintenance, so you just do the maintenance task and then you did not record anything, don't have any record. Who is the person who do this one? Okay, what is the changes has been applied to this part of the system? You did not record. Imagine how serious is the risk that may happen. Understand? Okay, so let's say for example, programmer A had made the changes, but they never update the document. Then programmer B go and do it. He treated this one is the changes. Okay, he treated this one is the existing. He don't know what is the changes there. Okay, then for the issue that may handle it, he may need to trace back to the previous version, but however, no record of that. So you imagine, is it how suffer the programmer is going to perform the task? Understand? Okay, and somehow imagine without versioning, like your GitHub, okay, if you want to roll back, you make a mistake, you want to roll back, you cannot roll back, then how? If your change is very huge, then you even don't know which particular code you have changed. Then are you going to do it again? Not possible, right? Isn't it? Okay, so this is version control actually is one of the activity of software configuration management. Okay, so therefore, software configuration management is to allow us to identify the items. Items here means any artifact, coding, person, tools, document, understand, or the process, okay, that is involved in a software development, okay, allow us, okay, and provide traceability of this item status. Understand? So this is the purpose of software configuration management. Okay, why so important? As just now what I have said just now, okay, so allow traceability to avoid any confusion. Understand? Okay, even though you know, okay, which version is the new one. Other than if you don't put the version thing, then if you want to amend, then which version you want to use, you also don't know. Which one is new one, which one is old one, you also don't know. Am I right? Okay, and then to improve the quality of the software, okay, to improve the efficiency on the software maintenance and the development, okay, and to reduce unnecessary costs in software maintenance, understand, or software development, okay. So this is some of the importance of software configuration management. Now look at the slide here. Goal of configuration management is to manage and control the numerous correction, extension and adaptation that are applied to a system over its lifetime. Like I said, you to record every single activity and every single move, every single changes, okay, and in the software maintenance. It control all the product items and changes to those items. Okay? SCM is the software configuration management applied to software product, include document, your coding, exe file, source code, hardware, disk, and so on and so on and so on. Understand? Okay? So configuration management, this is the explanation. Okay? It's a system engineering method that ensures a product attribute remain consistent throughout its life cycle. Configuration management is an IT management technique that tracks individual configuration pieces of an IT system in the realm of technology. Understand? Okay? So means that it allows identify all the items involved, allow traceability and around track, okay, around tracking of the item. So the configuration in the configuration means that the status, understand? The status of the item. Okay? So continue. This is the definition. As they say, identify the configuration of the system at a discrete point, okay, in the time for the purpose of systematically controlling changes to this configuration and maintaining the integrity and traceability of this configuration throughout the system lifecycle. Okay? This is another explanation. It's almost the same with the previous one. You can see that for software configuration management, you need to identify every version of the software, retain past version, provide a trial of audit for all the modification done, okay, throughout the software lifecycle for traceability and integrity. Okay. Now, what is the benefit? Reduce confusion, as I said just now. Allow us to evaluate, approve, and implement changes into a configuration item. Maintain product integrity. Correct product configuration. Ensure quality is ensured and better quality of software consume less maintenance effort. Okay, so these are the benefits. Continue with the benefit. Productivity is improved. Why? Because programmer and other stakeholders knows exactly where to find any piece of the software. You know the software status, then you know which software you are going to find, or which part you are going to find, or which version you are going to find. Liability is reduced, okay, by documenting the trial of action. Saving costs, okay. Reliable working environment, definitely because every status of the item, information of the item is consistent, okay, and updated, okay. So therefore, it help to provide a reliable working environment. Compliance with standard, accounting of status is enhanced, means that you know the status of every single item in your involved, in your software maintenance or software lifecycle. This is a theory. There are 4 elements of software configuration management. Identification of the software configuration means that know the artifact, identify all the artifacts involved, okay, in the software and their baseline, okay, and all those changes they have made. Control of software configuration, okay, this one is more on controlling how, okay, the items, okay, are being changed. Controlling how the items are being changed. Auditing software configuration, okay, so means that this one allow some sort like allow the user to know, okay, this one, okay, auditing. This one allow, okay, the integrity between the document. Let's say for example your requirement and your test cases and your design, okay. So if with the configuration management, okay, you will know that, okay, this design is to fulfill which requirement. Understand? Okay, and even though you know that, okay, which requirement is the newest updated requirement. Understand? So they maintain the integrity between the configuration items. Okay, so this is audit software configuration. Accounting software configuration status means that allow, okay, provide a history, okay, provide traceability of the status of configuration item. Okay, you can trace back, okay, the previous version. In software configuration management, okay, is discussed or described in the 3 technical dimensions of 4, okay, product, tools, and process. For the product, we have identification, version control, system model, and selection. For the product-wise configuration management, okay, what can do is the identification of the product, their information, their status. Understand? For version control, we can apply configuration for version control on the product to control all the different versions or release, okay, of the product. For system models, okay, it depends on what kind of models that we apply, configuration models that we apply, okay. So what kind of selection on the configuration model, what kind of schema we follow, what kind of identifier, what kind of standard we are practicing. For the tools wise, okay, in terms of tools dimension, these tools normally is for the workspace control, means that it's more on the working environment on the development of the software. Okay, let's say if you want to do some, a team is creating or developing the system, okay, so they must have certain environment provided to the team so that they can integrate, communicate, right, isn't it? And then maybe they can share also, they can publish the new release. So this is under the tools dimension. So workspace control, what is inside the workspace control? As simple as you can provide a sandbox. So fast. As simple as you can provide a sandbox, okay? One of the functions is you can provide a sandbox. You know what is a sandbox, okay? It's actually a share folder only, or a share space. Anyone can go inside and modify it. And then for the building, this one is a bit. This one is one of the functions of the workspace. Imagine your GitHub. Okay, allow us to build different release, upload, publish different delta. Understand? Okay, to the to share to all the developers. Okay, so this is the building. In isolation means that they provide a workspace that the programmer can have their own working environment, so that anything they do, it will not affect the existing one. Understand? So unless that the programmer is going to commit, understand? Publish and commit. So these are the 3 functions. Any question? Very straightforward, right? Okay. For this one, you imagine the GitHub, then it's easier for you to understand. Okay? So now come to the dimension. This is not the dimension. This is still under the. This is still under the tools. Building. Okay, building. Building is more on the release or delta management. Understand? Okay. So maybe you can build, create a new version, install it, and maybe you want to build a new version from the existing version, or maybe you want to modify the existing version. Then you can test, post, okay, all these versions into this provided workspace. Okay, so this is building. And come to another technical dimension, change management. Very simple. Software configuration management, okay, must be able to enable user to understand the impact of modification. Okay, enable user to identify the product which a specific modification apply, provide maintenance personnel with tools for change management. Okay, what do you mean by this one? So first, enable user to understand the impact of modification. For the software configuration management, okay, so it may, for example, it may allow, okay, let's say I want to modify this module. Software configuration management must provide certain information that, okay, what are the module that is related with this module one, okay, and which version of this module is it now, okay, so that they can know when they modify it, which part will be impacted, and enable user to identify the product, because in software configuration management, each item has a unique identifier. Similar case, your software requirement, each requirement has an ID, right? Isn't it? Why we need to have ID? Easy for us to identify the requirement. Okay? So, and then provide certain assistance or tools, okay, in helping the user to perform the change management. So the last one, okay, status accounting. Okay, status accounting. So this one is more on the property or status of a particular configuration item. Okay, so what is the purpose? To keep formal record of already existing configuration. Means to record down all the information that is related to items in the project. Produce periodic report to show the status of the configuration. Okay, so why we need to produce this report? Actually, is useful for describing the product correctly. Are used to verify the configuration of the system for testing and delivery, maintain history of the change request. Okay, so this is the functions. Auditing. Process, okay, correct. Auditing. Auditing, what is it by auditing? Okay, allow the system to be rolled back to the previous stable release, okay, allow changes to be made, okay, and we know that what are the changes we made, who is the person who made it, okay, when they make these changes, understand? Okay, there is two different audits, okay, that is performed in the software, okay, before the software is released. First one, audit for functional configuration. Make sure that, okay, to determine whether the changes you made, okay, satisfy the user and the system requirement or not. Audit for physical configuration, okay, so make sure that the program you have modified is presented appropriately, understand? Okay, based on your design and other references. This is the SCM process. This diagram shows the SCM process, software configuration management process. There are 3 stages or 3 phases. Okay, the first one, plan SCM program. before you start your software project management, you have to plan how are you going to perform your software configuration management. Okay, plan it. Okay, what are the process? Let's say for example, what are the process you should apply? How many steps in the process when you want to change the system? Understand? Okay, so what is the process you should follow? Okay, or what are the info you should record? Okay, when you confirm the release of the change. Understand? Okay, this you want to plan it. Means plan the how are you going to perform the software configuration management. Then identify who is the stakeholder, who is the person involved. Develop or procure the SCM tools. If you feel that you need certain tools to help you in the software configuration management, either you develop yourself or either you go and purchase them. Understand? Okay? After that, then the second stage or second phase, establish baseline. You need to establish an initial baseline for each of the item configuration. Means that you need to establish the status, okay, of each item involved in your project development or involved in your software maintenance. Okay, what is the initial status of your system? Okay, identify those items and then record down their information, identify their status. Okay, so you achieve a baseline already. Now, develop schema or identifier. What I mean by identifier here actually is your number, unique number, your requirement ID, your design ID, your document ID, your project ID, your versioning. Okay, how is it should be look like? Is it just 1, 2, 3, 4, or you should have different portions separated by dash or dot or whatever? Understand? The schema, the structure of your identifier. Okay. After that, then this is an iterative process because changes is being made from time to time to the system, right? So for this stage is more on the control of the change management. Okay, control of change. First one, evaluate proposed changes and approve or disapprove. When there is a changes happen, you need to evaluate whether these changes can proceed or not proceed. Maybe you can consider in terms of cost, maybe you can consider in terms of the impact or other factors. Understand? Go or no go. When that is a change request come in. Second, track approved changes. If approved already, then you have to track the changes. What has been done, what has been modified, which part, who do it, when do it. Understand? All need to record down. Update baseline. After you track it, then you keep on update lah. The necessary document or related document. Okay, and the history. Publish the report so that everyone will know the latest info or updates. Understand? Audit, compare. Then after that, you compare with others related artifacts. See whether they are consistent. Okay, they are matched with each other or not. Understand? Okay, so this is thing. And then if another CR, again and again. So this is the SCM process. Oh, finished already. Those slide after this one is the explanation of this one. Understand? So you please have a read there. I guess I have explained already. This is the chapter. Or you want me to go through the balance slide with you again?
Balance slide?
I mean the balance one. This slide actually is the explanation of this one, in which I just now have covered already. Or you want me to cover one by one again with you? So SCM process, okay, we start with this one, establish baseline. This one is the planning, okay, they won't have any description, just to plan out, okay, first step, what is to define identify the process of SCM, to identify the stakeholder, to find some tools, okay, so this is very straightforward. Now the slide here, they start with the established baseline, okay. So to find out if something is subject to configuration management, okay, you need to find out, establish a baseline means that you want to know the status of the item involved in your software project. Understand? Okay? So after the configuration has been identified, a baseline library is constructed. So you need to have a repository or library to store all these record one. Understand? Okay? The library, also known as repository, okay, is the heart of the SCM. All public configuration must be saved in the repository. Means all the record regarding the information of those configured items must be stored in the repository. And this repository is shared among the stakeholder or the developer. Understand? So now, these are the activity involved in identify the baseline, okay, in achieve the baseline. Create a snapshot of current version of the product, check the configuration and assign the version number, okay. So store the approved information in the repository, and all of the following information should be distributed to all stakeholders. Create a schema of word number or letters to represent all configuration item. Schema means the structure, understand? Okay, so maybe your identifier is combination of word, okay, number or symbol, okay, let's say for example for your requirement ID, okay. So controlling and documenting, auditing, okay, so this one, after you have got your established the baseline, then move to this one, controlling, document and audit, okay. So this is, as I said, this one is more on change management, how we control the change, how SCM support in the controlling of change, okay. So after you establish the baseline, you make sure that all the artifact is correct, the information is correct, and the status is tally with each other. Understand? Okay. So when there is a change come in, okay, so you need to record every changes that have been made, okay, update every changes, and maybe after or at some certain point of time, okay, you may need to perform an audit, make sure all the document is updated and all the document is correct. Understand? Okay. So and all the relationship, all the connection between the document is also correct. You get me? Let's say for example, your test case. This one test case is to test the requirement 3.1. Then you go to the required SRS. Actually, you found that make sure that the 3.1 is what the test case is intended for. Understand? Okay, so this is to audit, understand? Okay, so and make sure that all change activity is the document is up to date and comprehensive. This is the controller. That's it. Understand? Okay, so this is the configuration management. Any question? Ask. Any questions? Activate retina scan. Okay. No question. I think some of you don't understand what I'm talking about. Okay. So, okay. So this is chapter 5. Any questions? No question, Person. Any question? Okay, no question. Then how about Regina, right? Regina or Regina? It's me. It's me. Okay, forgot your name, sorry. Okay. How do I address you? Sorry? Renisha. Renisha. Oh, Renisha. Renisha. Any question? No question. Then your friend there? No question. How about at the back of the row? No question. No question is because of already understand or don't understand. Then how about this side? Cataract. Yes. Hey, cataract. Look in my eye. I need to do a retina scan. So, understand? Any question? No. How about student at the back? Any question? Okay. Hey, you really need to understand. If any question, you please come and see me. Okay. Okay. Now. Wow, so early. Okay, I can't. Starting next week, we are coming to a very interesting topic, which is called the software re-engineering. So far, you always call software engineering. Okay. Now, next week, we are going to start a new topic called software re-engineering. And this topic covers two chapters. Okay, it's a quite huge topic, and that is quite a lot of terms you need to understand. Okay, so therefore, before we go to this chapter, let us have a very, very brief understanding on what is meant by software re-engineering. Okay, now, class, during a software maintenance or during the life cycle of the software, sometimes we may need to, build something, okay, by modifying something new, okay, by modifying your existing system, either partially or either we need to build a new system based on your existing system, okay. So therefore, this process is called software re-engineering, okay. And for software re-engineering, there are two main processes. One is reverse engineering and another one is forward engineering. Okay? So far, what you learn is more on the forward engineering. Okay? Reverse engineering, there are a lot of meaning behind. But in our software maintenance subject here, okay, reverse engineering actually is the activities, process you study on the existing system, okay, to come out with a high-level representation of the existing system. Okay, maybe it's the entire system, or maybe it's just a part or the intended part of your existing system. Understand? Okay, I understand that. Okay, for reverse engineering in software security, okay, there is another meaning on that. Understand? But for example, decompilation. In our software engineering here, this subject is to change or to revive or to get the source code based on the execution file. Understand? However, for software security, there is another meaning. They may intended that there may be a illegal act on the software. Understand? Okay. But here, our software engineer student is very professional one. Okay. We don't do anything illegal one. Okay. So in this case, software reverse engineering actually is to study the existing system, or maybe part of the system, and to get the higher level representation of the system. Understand? This higher representation of the system not necessarily should be the higher level architecture of the system, okay? Or maybe it's just some high level design of the system also can be. Depends on your needs, understand? Okay? But in overall generally, we say that to study the system and get the higher level representation of the system. Okay? Which level is the highest? The conceptual level. Okay? If you want to reverse until the conceptual level, that is possible also. Understand? Okay? So this is reverse engineering. Once you get the representation of the existing system, then you may, based on what you get, then you may make certain changes, alteration, and then you start to develop the new system, so-called new system, based on the existing one. Understand? What you have get, okay? Then you try to modify it, develop, and to become a new system. So from this stage to the new system is called the forward engineering. Understand? Okay? It's called the forward engineering. Definitely there are many step process to follow lah. Okay? So this is a re-engineering. Understand? Is to restructure your existing system, maybe to produce a new one. Why we need to do re-engineering? Sometimes it's because maybe your documentation is not sufficient. Okay, the system is very old already. Okay, so this is some of the possible reasons. Understand? Okay, so this is re-engineering process. And re-engineering, okay, there are some theory lah, okay, inside there that apply certain theory or principle, not the theory, principle method. Apply certain principle, okay, principle of abstraction, principle of automation, and principle of refinement. Okay, so what is meant by principle of abstraction? Means that the level of information, okay, the abstract level of information will increase. Abstract level increase means that become more simple. Abstract simple, right? See? So abstract level increase means it becomes simple. Understand? Principle of refinement is the abstract level will reduced to provide more info. Abstract level reduced means that more people, right? Isn't it? So which engineering main process is applied abstraction? Reverse engineering apply the principle of abstraction. Forward engineering apply the principle of refinement. Okay? Then how about alteration? Alteration is referring to the changes you made will not affect the abstract presentation of the system. So this is the principle of alteration. Maybe you just rewrite the system using another language. Okay? So it will affect the higher level presentation. Understand? Okay? So this is the three principles. Any question, class? I'm not going to continue. Just let you know what is meant by re-engineering already, sufficient already. Okay. Next week we are going to go into each of the slides there. Okay. And that's it. Okay. You want to talk so many, will confuse you one. Okay. So remember this one. Starting this topic until the end is in your exam. Okay. Starting chapter 6 until chapter how many chapters? Chapter 13, if I'm not mistaken. Okay, is your exam chapter. Okay. Any question? Any question? From the motion sensor, I can see that most of you is eagerly to go back. You can see so many sensors. Okay. When you teach IT or computing subject for very long time, the way I speak also like a very technical one. Okay. Yeah. So. Okay. Any questions? No questions. I guess you can dismiss already. Okay. And if you have any questions, you can step back and ask me. I will be here. Okay. So until all the students leave the venue lah. Okay. So yeah. Sign attendance You still got time to sign attendance. Okay. So I see you in the practical or either next week lah, or some of the group. Okay, so those who want to leave, you may leave already. Okay, so my ask also I think the answer.
Don't worry, I believe they have good progress on.
Okay, thank you. Yeah. Thank you.
请问你要最后是哪？我要去哪边？就是
你今天是回家还是？我先走啊。
Your apartment
housemate.
housemate lah.
Girlfriend.
Yeah.
Yes.
你还要充电吗？
how come your Oh, they are senior group, right?
Senior.
Then, oh, maybe they do.
very stressed. I feel like my FRP should be a team project lasting for months, but then now week 5, week 6 need to test already. Wow. One person, solo team.
Yeah, in the team project or
Solo. Oi, 不要，我们
怎么不想我嘛？因为你，
哎，不要这样。
我们有比这个。
不会。
Hey, how is your progress?
没有。
Yes.
我也跟你讲。
那个